Welcome to the lecture series of Modern Digital Electronics. In our next couple of classes, we will be learning about number system and codes. In our next two classes, we will be learning about number system conversion. In today's class, we will be converting a number from its own number system like binary, octal or hexadecimal to decimal number system and vice versa. Like a number in decimal number system, we will be converting to corresponding binary number system or octal number system or hexadecimal number system. So let's start the class. First, we will convert a number which is given in binary number system to its equivalent decimal number system. Now we know in binary number system we have only two possible digits and they are 0 and 1. Similarly, in case of decimal number system, we know that we have 10 digits there from 0 to 9. Now in this number in binary number system, what we can see here, this number has a decimal point and before that it has an integer part and after the decimal point it has a fractional part. So we will be converting the integer and fractional part separately. So what we will do is first we will write the digits of integer part and then we will write the digits of fractional part. In integer part, this is our least significant bit and in short we represent that by LSB, and this is our most significant bit, MSB. Similarly, in case of fractional part, this is our MSB, most significant bit, and this is our least significant bit. Now what we will do is we will multiply 2 to the power 0 with least significant bit. Why 2? Because in case of binary number system the base is 2 and here the power will start the power from 0. Now with the next digit we will multiply 2 to the power 1, then with this digit we will multiply 2 to the power 2 or 2 square, then with this 2 cube. Similarly with this it will be 2 to the power 4 and then we will add all these terms, and this representation we have already studied in school level mathematics when we studied playing with numbers. Now on the other side we will multiply 2 to the power minus 1 with most significant bit and then similarly it will be 2 to the power minus 2. Gradually it will decrease. Here in case of integer part we are multiplying by 2 and gradually we are increasing the power of that base 2 by 1, and in case of fractional part we are dividing by 2 and gradually we are increasing the power by 1 for every consecutive bit. So here this 1 will be multiplied by 2 to the power minus 3, means here 1 will be divided by 2 to the power 3. Next this 0 will be multiplied by 2 to the power minus 4 and then again we will add all these terms. Now when we will simplify, the first term will be 16, then the next term will be 8 but it is multiplied by 0 so that term will vanish, then it is 4, then the next term will be 2 and then 2 to the power 0 means 1, and when 1 will be multiplied by 1 it will be 1, and then we will come to the fractional part. It will be 1 by 2 and then multiplied by 0 so that term will vanish. Next it is 1 by 4 and 1 by 4 in fraction that will be 0.250. Next 2 to the power minus 3 means 1 by 2 to the power 3, 1 by 8. So 1 by 8 if we represent in fraction then it will be 0.125. Then it is 2 to the power minus 4 whatever. Since this digit is 0 so this term will vanish. So then if we further simplify then it will be 20 plus 3, 23, and from the fractional part it will be 0.375. So finally it will be 23.375 and that is the equivalent number in decimal number system. Next, we will convert a number which is given in decimal number system to its equivalent number, which will be in binary number system. And what we can see here is the number in decimal number system again has integer part and fractional part. Now, when we will be converting from decimal number system to any other number system, what we will do is we will convert the integer part and fractional part separately. For the integer part, what we will do is we will divide the number or the integer part of that number by 2 here, because we are converting this number to binary number systems, and we will record the remainder of that division. So in our case the number is 53 and we will divide 53 by 2, since we are converting to binary number system. Now when we will divide 53 by 2, the quotient will be 26 and the remainder will be 1. Now next what we will do, in the next line we will divide the quotient by 2, the quotient will be 13 and the remainder will be 0. Fine. Next what we will do, we will divide 13 again by 2 and we will record the quotient and remainder. Here the quotient will be 6 and the remainder will be 1. Next we will divide 6 by 2 and similarly we will record the quotient and remainder. Next we will divide that quotient 3 by 2. So here the quotient will be 1 and the remainder will be 1. Though this number 1 is less than our base 2, but still we will continue with our division unless the quotient becomes 0. So in the next line or in our last line we will divide 1 by 2. So in this case what will be our quotient? It will be 0 and the remainder will be 1. Now we have obtained this series of binary digits. So how we will represent this 53, this number in binary number system, is this last digit of the remainder will be considered as our MSB, means most significant bit, and the first digit will be considered as our LSB, and accordingly we will be writing. So since this number will start with most significant bit, so it will be 1, then 1 0, then 1 0 1. So this will be the binary equivalent of the integer part of this number which is given in decimal number system. Next what we will do is we will take that fractional part which is 0.625 and then we will multiply that part by the base of that number system to which we want to convert. So one thing what we have noticed here in our last problem, we converted from binary to decimal number systems. For integer part we multiplied and for the fractional part we divided. Here we are converting from decimal to binary number system. For integer part we have divided and for fractional part we will be multiplying. So here when we will multiply 0.625 by 2, the result of multiplication will be 1.25. Now what we will do is we will record the integer part of this number which is 1 in this case. Now next what we will do, we will take the fractional part from here which is 0.25 or 250, then we will again multiply by 2 which is the base, and here the result of multiplication will be 0.50. So what is the integer part of this number? That is 0. So we will record that number. Next what we will do, we will again take the fractional part which is 0.50 and then we will multiply by 2. This time the result of multiplication will be 1.00. So the integer part is 1 and we will record that. And here the fractional part is 0, so we can stop our multiplication here only. Otherwise, even if we multiply, if we continue with our multiplication, then it will be 0.00 and that will be multiplied by 2, so it will be 0.00 only. So we can think this way, that we will stop our multiplication when that number will be 0.00 in that form, means the final value of the integer and fractional part will be 0. So there we will stop our multiplication, and here here the integer part of this number will be 0. Now whatever the digits or the bits we have received here, now we will write. And what is the rule of writing here? This will be considered as our most significant bit of the fractional part, and this will be considered as the LSB or less significant part of the fractional part. So the equivalent fractional part will be 0.101, since this is our most significant bit. And finally the LSB is again 0, and since after decimal point if we have 0 at the last position, then it doesn't contribute anything. That's why even if we stopped our multiplication here itself, that didn't create any difference in our result, because we are getting 0 only at the last position of the fractional part. So this will be the binary equivalent of the fractional part, and when we will merge these two, then the final number in the binary number system will be this. Next we will convert a number which is given in octal number system to its equivalent number in decimal number system. Now we know that in case of octal number system, the possible digits are from 0 to 7, total 8 digits. So if we look at this number, we can see here the integer part and as well as the fractional part, all the digits are within 0 to 7 only. And the rule of conversion will be the same that we have seen or applied when we converted from binary to decimal number system. So first we will write the digits of integer part and fractional part, then we will multiply by corresponding factor, but this time since we are converting from octal number system, so here the base will be 8. So here it will be 8 to the power 0, it will be multiplied by 8 to the power 1, it will be multiplied by 8 square or 8 to the power 2. Then what we did in case of binary number system, we added all these terms. So here also we will be adding all these terms. Now next in the fractional part, it will be multiplied by 8 to the power minus 1, it will be multiplied by 8 to the power minus 2, and here similarly 8 to the power minus 3, and we will be adding all these terms. Next we will simplify, and after simplification it will be 8 square means 64, 2 multiplied by 64 plus it will be 6 multiplied by 8, then it will be 5 multiplied by 1, 8 to the power 0. Then in the fractional part it will be 7 divided by 8, and that means it will be 7 multiplied by 0.125. Next 3 divided by 64, so it will be 3 multiplied by 1 divided by 64 is 0.0156 plus 1 then multiplied by its corresponding fractional value, which is 0.00195. Now if we simplify further, then it will be 181.92375, and this number is represented in decimal number system, or we can say this is the equivalent number in decimal number system of this number in octal number system. One thing I want to mention here is this 0.00195, this value is approximated value. Here I have approximated till 5th digit after decimal point, so the final value that we have obtained here, that is also an approximated value. Next we will convert a number which is given in decimal number system to its equivalent number in octal number system, and again here the rule will be same as that we have seen in case of decimal to binary number system conversion, but here the base will be 8 instead of 2. So first what we will do is we will separate the integer and fractional part. So here our integer value is 444, and what we will do, we will divide this value, this number, by this number, base of this number system, which is 8. So here the quotient will be 55 and the remainder will be 4. Fine. Now next what we will do, we will divide 55, the quotient generated in this line, by the base. 8. So here it will be 6. The quotient will be 6 and the remainder will be 7. 8 6 are 48. 48 plus 7 55. Next what we will do, we will continue with our division. We will take this quotient and we will divide by 8 unless the quotient becomes 0. So in this line the quotient will be 0 and the remainder will be 6. So what we have seen in the previous example, this was our MSB, or here most significant digit, MSD, and this will be our least significant digit. So the integer part in octal number system we will be writing this way, 674. So this will be in octal number system. Now next we will proceed with our fractional part, and for that we know that we will multiply by 8 the base of that number system. So here the fractional value is 0.456 and that we will multiply by 8. So when we will do that, the result of multiplication will be 3.648. So what we will do, we will record the integer part of this result of multiplication and we will take the fractional part, which is here 0.648, and we will continue with our multiplication. So that will be multiplied by 8 and the result of multiplication here it will be 5.184. So we will take the integer value here, we will record that, and we will continue with our multiplication. Here again it will be multiplied by 8. This result of multiplication will be 1.472. Here again we will record the integer part, which is 1 here, and then we will continue our multiplication, 0.472, and then we will multiply by 8. So here the result of multiplication will be 3.776. so we will record the integer part again and then we will continue with our multiplication. So this time it will be 0.776, and when it will be multiplied by 8 it will be 6.208. Now we know that this type of multiplication we continue unless this result of multiplication becomes 0, but we have already performed multiplication 5 times here, and till we are far away from becoming this result of multiplication 0. So what we will do, or what we may do, is we may approximate our result till maybe 4 digit or 5 digit or maybe higher digit for higher accuracy. This time we will approximate till 5th digit, and so even though this is not 0, we will stop our multiplication here, and the final result that we will be getting, that will be an approximated one. Like the previous example, there also we approximated till 5th digit. So the equivalent value in octal number system will be what? We know this time this will be our most significant digit and this will be our LSD, least significant digit. So it will be 0.351 then 36. That will be in octal number system, and when we will merge these two values together, the final value will be 674, then the fractional part 0.35136. that is, this is the equivalent number in octal number system. Next we will convert a number in hexadecimal number system to a number in decimal number system. Now in case of hexadecimal number system, we know that we have 16 digits, so it will start from 0 and it will end at 15. But we also know that from 0 to 9 we represent by normal digit that we have in decimal number system, but 10th digit onwards we represent by alphabets. So here 10 is mapped with A and accordingly we increase. So finally 15, which is the last digit in hexadecimal number system, that is mapped with F. So in hexadecimal number system we know that the digits are from 0 to F. So if we look at this number in hexadecimal number system, we can see here that all the digits are within this range only. So now we will convert in decimal number system, and the rule is same that we have seen in case of binary and octal. So we will first write the digits of the integer and fractional part, and then the digits of the integer part we will multiply by this. Here this time the base is 16, hexadecimal number system, so it will be 16 to the power 0. It will be multiplied by 16 to the power 1, and it will be multiplied by 16 to the power 2. Now it will be multiplied by 16 to the power minus 1, it will be 16 to the power minus 2, and it will be 16 to the power minus 3. And then we will add all these terms of the integer as well as fractional part. This rule we know. Now what we will do, we will complete our simplification, and this time as we can see 2, 3, 3, 5, 1, we don't have any difficulty. We will not face any difficulty in multiplication. But A here we will be taking the value of A as 10, and we will complete our multiplication. So this will be 10 multiplied by 16. Square of 16 means 256. Then the next term will be 2 multiplied by 16. Then it will be 3 multiplied by 1, and the fractional part it will be 3 multiplied by 1 by 16. 1 by 16, the approximated value is 0.0625 approximated till 4th digit. Next it will be plus 5 multiplied by 1 by 16 square, so 1 by 256, and 1 by 256, again the approximated value will be 0.00391, and then 0.0002441, which is again an approximated value. Now if we simplify further, then it will be 256 multiplied by 10, so 2560, then it will be 32, 16 twos are, and then it will be 3, the integer part. The fractional part will be, it will be 0. The first value will be 0.1875. I repeat, this is an approximated value. Then the next part will be 0.01953, and then the last part or last term will be 0.0002441. Now if we further simplify, then the final result, final number will be 2595.20727, and this number is approximated till 5th digit after decimal point, and this is the number, equivalent number in decimal number system of this number in hexadecimal number system. Next we will convert a number in decimal number system to its equivalent number in hexadecimal number system. So we know the rule. This time only the difference will be in the base, and which is 16 this time. Now what we will do is we will separate the integer part and fractional part. With the integer value we will divide, and this time we will divide by the base, which is 16, and with the fractional part we will multiply, and this time the base will be 16. So we will divide 125 by 16, and from this division the quotient will be 7 and the remainder will be 13. So we will continue with our division. So next time the 7 will be divided by 16. Here the quotient will be 0 and the remainder will be 7. So as we know, this is our least significant digit and this is our MSD, most significant digit, and accordingly we will be writing. So first we will write 7, the MSD, and then 13. But in hexadecimal number system, 13 is equivalent to D, as I have discussed earlier. So it will be 7D, and that is represented in hexadecimal number system. Next we will multiply the fractional part. So fractional value here, it is 0.201, that will be multiplied by 16. The result will be 3.216. So we will record, or we will take the integer value, which is 3 here, and then we will continue with our multiplication. This time the fractional part is 0.216, that will be multiplied by 16, and the result here it will be 3.456. so we will take the integer value, which is again 3 here, and we will multiply the fractional part again by 16. This value will be 7.296. we will again take the integer value, and we will continue with our multiplication with the fractional part. 0.296 multiplied by 16. This time the result of multiplication will be 4.736. we will record the integer value. We will continue with our multiplication with the fractional part. This time the result of multiplication will be 11.776. so we will take the integer value, which is 11. Now we have already performed this multiplication 5 times, and we still this result of multiplication is not 0. that means we have to continue with our multiplication. But this way, how long we will continue? If this is an infinite rational number, then we cannot continue with infinity. So we have to approximate somewhere. We may approximate till 4th digit or 5th digit. So since we have already multiplied 5 times here, so that means we are approximated till 5th digit. So accordingly, we will be writing the equivalent value in hexadecimal number system. But all these digits or values that we have obtained here, they are in decimal number system. So we have to, since this time we will be representing in hexadecimal number system, so we have to represent accordingly. So in hexadecimal number system, 3 is 3 only. So 3 3, and 7 is also 7 only. 4 is also 4 only. But 11 is represented by B in hexadecimal number system. So the fractional part, as we know, this is our MSD, most significant digits. So the fractional part will be written this way: 0. Then 3 will be starting from here, 3, then 3, 7, then 4, then B. So this is our fractional part in hexadecimal number system. So the complete number in hexadecimal number system will be 7D, which is the integer part, and then decimal point, and then 3374B. so this is the hexadecimal equivalent of this number in decimal number system. So this is how we proceed with a number which is given either in binary, octal or hexadecimal number system to its equivalent decimal number system, and from decimal to all these number system. This is the rule. I hope you have learned the concept clearly, and whenever you will be given a number, whatever is the number, you will be successfully converting to its desired number system. So with this, I end today's class. See you in the next class. Thank you.